Okay, we're starting polynomial functions. So we've already learned about linear functions back in Math 10. So some examples are there. Y equals 3x plus 12, y equals negative a half x plus 3, y equals 2x. Those are all in slope y-intercept form. They are linear because the exponent on x is 1. Okay, so the degree of these functions is degree 1. Okay. Also studied quadratic functions in the last unit. So y equals x squared. X squared is the highest degree term. So the first two are in standard form. Then this is in vertex form. This is in factored form. All of these can be expressed in standard form. So y equals expanded out and like terms collected. These are quadratic because the highest exponent on x is 2. So the degree of the function is 2. Okay. Linear and quadratic functions are examples of polynomial functions. Here are some polynomial functions of a higher degree. So cubic, that means the highest degree term is cubed. Okay, and you can see here, if you have to expand that out, that's going to be x squared. And then an x squared times an x is x cubed. So the first term will be, in this case, actually, it'll be 2x cubed plus a whole bunch of stuff. Quartic, degree 4, and again, this will be 2x times x times x times x. That's going to be y equals 2x to the 4 plus a whole bunch of other terms. So degree 4. Quintic is degree 5. Notice how we usually express in descending order of degree or in factored form. So this will be x times 2x is 2x squared times x is 2x cubed times x squared is 2x to the 5th. Plus a whole bunch of terms. Okay? So there's the sort of the general case. So a subscript n is the coefficient of x for the exponent n. So this is, so it's just kind of naming off the different, instead of using a, b, c, etc., because we don't know how many terms there are. Okay, n is a whole number, and the coefficients in constant term a sub n to a sub 0 are real numbers. The highest power of the variable x is called the degree of the polynomial. Coefficient of the term of highest degree, so that's this, that's called the leading coefficient. Because when you express it in standard form, in descending order of degree, that's the leading term. Term with no variable is called the constant term. Okay, so in this case, the general case, the degree is n. The leading coefficient is a sub n, and the constant term is a sub 0. Okay. Which of the functions below are polynomial functions? Remember, polynomial functions can't have fractional exponents or negative exponents or decimal exponents, that kind of thing. So for the polynomial function, state the degree, leading coefficient, and constant term. So highest degree term is 4. All of the terms are have exponents that are whole numbers. So it is a polynomial function. Degree is 4. Coefficient of x to the 4th is negative 2. Constant term is 1. Next one, take a look. It's degree 3. Then there's 2. This, though, means it's not a polynomial function. Okay, it's still of degree 3, but it's not considered a polynomial function. It still has a leading coefficient of 5 and a constant term of 3. Okay, even though it says only do this for the polynomial functions, you can still fill in some of it. Next one, notice how there's x in the denominator. That's the same as, that term there is the same as negative 5x to the negative 1. So that is not a polynomial function. Okay, so you could still consider it, I think you could still consider it degree 2. Okay, highest degree. Leading coefficient would still be 8. But this actually would be a rational. So not that you didn't really, so I'm going to put these in brackets, You're not necessarily going to use that. Constant term, for sure, you could still use. Okay? Then this one here, when you expand this out, so this would be 2x squared, then you're multiplying everything by negative 4x. So that's going to be negative 8x cubed plus all the other terms. So that's going to be a polynomial function, degree 3, leading coefficient negative 8. Constant term, you don't have to expand everything out. Take a look here. So the last terms here would be negative 15, and it would have to multiply by negative 4x. So there actually is no constant term in that. Okay. In this course, for all polynomial functions, all the coefficients will be integers. These types of polynomial functions are called integral. Okay, not to be confused with taking an integral in calculus, but they're called integral polynomial functions. So review of x and y intercepts of linear and quadratic. So review of Math 10 last semester. Y equals 2x minus 5. Y intercept is the constant term. X-intercept is when y equals 0. So we have 0 equals 2x minus 6. This is algebraically, so we'll show the work. So 6 equals 2x, so x equals 3. And it says graph using the x and y intercepts. So y-intercept is negative 6. X-intercept is 3. We're doing a sketch, actually. So it says sketch the graph. So I'm not putting a scale on it. Oops. What am I doing? I just need to put arrows. Okay. So x is 3, this is negative 6, and that's it. Okay. Next one's quadratic. State the y-intercept, negative 8. Algebraically determine the x-intercept, so that's when y equals 0. So that's going to be 0 equals x squared minus 2x minus 8. We did this last semester as well. So you factor. So x equals negative 2 and positive 4. And use the x and y intercepts to sketch it. And so really we've already learned from the last unit. We could also algebraically determine the vertex form, right? So we do know that the axis of symmetry is halfway in between. So halfway in between negative 2 and 4 is 1. Maybe that's not quite. So that looks kind of more like halfway in between. And y-intercept is negative 8. So we know we have to just estimate here. Make sure a vertex is on the axis of symmetry. And then this would be negative 8. Okay, we could find this point, given this, the x value at that vertex is 1, right? Because the axis of symmetry is the x equals negative 2 plus 4 over 2, which is 1. That's the equation of it. So that's going to be 1. We could then substitute back in to our equation. 1 minus 2 is negative 1, minus 8 is negative 9. So vertex is 1, negative 9. And graph it that way. So you don't even have to complete the square. Okay. So we sketch that. Now, from those, they are expressed in simplified form. When the equation is expressed in simplified form, the y-intercept is obvious. It's the constant term. So here, negative 6, here 1, doesn't require any work. When the function is given in factored form, an equation, it's easy to find the x-intercepts, right? So y-intercept, it's easiest when it's in simplified form. X-intercepts when it's been factored. So here, x-intercepts are 7 and negative 3 over 2. Here, x-intercept is negative 3. Here, there's 3 of them. So 2, 5/3, negative 1/2. Whatever makes each factor equal to 0. So you're basically solving each of those. Right? So it's opposite sign of the constant, divide by the coefficient. Opposite sign of the constant, divide by the coefficient. Next one. Here, when there's just a factor of x, nothing added or subtracted, it's 0. This one is opposite sign of the constant, divide by the coefficient. And this, when we try to solve this equal to 0, you'll see that there aren't any solutions. You can't take the root of a negative. So there are no solutions from that. So there's just 2 on that one. Okay. But notice how if you have linear factors, then this is degree 2, we have 2 solutions. This is degree 2, we have only 1 because there's only, it's a repeated factor. This has 3, okay, this has 2 because that other factor can't be solved. Okay, and that's it.